Right, the Stormworks Basics is going to be a jet turbine controller. So it's going to be very simple again, the whole point of Stormworks Basics. Um, so we'll start with just making a base for this to sit on. So my degree is in aeronautical science, so one of the classes that I had to take for my degree was turbines. So I'll be referring to these jet turbines as turbines. It may be a little bit confusing because we have in-game steam turbines, but that is the proper terminology for a jet turbine, is a turbine. Um, so that's why I'll be using that term. So that's what it is. Again, I had many courses on jet turbines. So let's go ahead and let's get to the jet parts. So let's go over them really quick. So we have a jet combustion chamber, jet compressor. These are just ducts. We have a couple exhausts, or 3 exhausts here. We have 2 turbines. We have jet turbine medium and small. The only time I ever use a small is if I'm making just a jet plane that I just need thrust. Pretty much always use a medium turbine because they have a torque output on them. As you can see, we can get power RPS there. And then we have a large intake, and we have a jet intake, small jet intake. So let's go ahead and let's start with a compressor. All right, so I'll go through the theory a little bit, seeing this is what my degree is in. So let me just put a fan on it too. Okay, so let's just build a real quick one, and then I'll go through the components. So we need a compressor. We need a jet intake. I'll end up using the proper terminology. Then we want a combustion chamber. If you look at the arrows, you want the arrows pointing backwards towards where the quote-unquote thrust will go. And then you want a turbine. All right, and so as you can see, that has a power output. I'm just going to put that down. Okay, so now I'm not going to put, now if I wanted a regular jet that just powers a jet airplane, I could go like that. That would give me thrust. If we look at the node here, I can spoil the thrust, i.e. open and close it. That's not really how it would work. But so we're not going to do that. I'm going to just set up a test bench here that will work like a generator, and that way that will kind of show you the basics. The other thing you could do is if you wanted to add if you wanted to make a turboprop. A turboprop is a jet turbine that then powers a propeller. So you would take piping, and out of this RPS here, you would put a propeller. If you wanted a turbo shaft, that would be a helicopter. You would, out of this power output here, you would hook it to a rotor. All right, so we're not going to go into that right now. So let's get a tank. I'm just going to get a large fluid tank here. Now, a jet turbine is going to be very thirsty, just like in real life. A jet turbine, the benefits of a jet turbine in real life are they're incredibly simple. And so one of the things with that is that cuts down on maintenance. That makes them very safe. They have very low vibration. They give you a lot of power in compact spaces. Like you can have a small jet turbine powering a helicopter, and it would be very tiny and light compared to if you had a reciprocating engine. Reciprocating engines add a lot of vibration, which you don't want, in an aviation context. But jet turbines are most efficient at high speeds, at high altitudes. All right, that's where they really shine. And so a lot of people you'll see they're making their boats. Jet turbines, you're going to be eating a ton of fuel, which is fine if you want to put on infinite fuel or put massive fuel tanks, but practically diesel is going to be much better for those applications. Jet turbines are going to be much more useful for the applications where they are in real life, like a turboprop, a turbo shaft, or jet aircraft themselves. Or you have an enormous boat and you need to make a ton of electricity. So let's start here. So fuel tanks connected right to the combustion chamber. Let me kind of go over the theory again, since this is what my degree is in. So how does a jet turbine work, and how does it work in game? So a real jet turbine, you have your intake fan here, which is known as your N1 fan. All right, so this air is drawn in. It goes through to the compressor. Now there's a constriction. So the diameter is going to get smaller. So generally you have a bulbous area in the middle here where your N2 blades are spinning. And then the air is forced to go around these sides like this. And so what happens is you have fast air coming in. Now as it goes into a constriction, the air starts slowing down and the air starts compacting. And so that compaction is compression. And so at high altitude you have very thin air. and so you need to compress that air. So that air is compacted. It slows down because if it was going too fast, it would just blow the flame right out. So you need the air to go slower, and you also need the air to compress so that you have enough air to mix with fuel to combust. So then you come into your combustion chamber, and you have what are called burner cans. And so the compressed air comes into the burner cans. It's mixed with fuel. At least for the starting phase, you have igniters on. They're just electrical igniters like spark plugs. Once the turbine is up and running, you don't need ignition anymore. The pressure's high enough, the heat's high enough that the fuel will almost instantly combust. Once you get combustion, that gas rapidly expands and it needs a place to go. It has a lot of high pressure air in front of it. So where does it want to go? It wants to go back to the area of least resistance. So then you go into the turbine section, and there are a couple sets of turbine blades. So let's say there are four. We have one here, one here. The hot gases come over and they hit these turbine blades here. All right, there's a shaft connecting those turbine blades, and the shaft goes all the way up and it connects to this fan in the front. That's your N1 fan. So the turbine blades back here, because of the hot gas expansion and spinning them, is actually what turns the fan in the front. Then you have two more blades here. The hot gases continue through. They spin those blades up. There's a shaft connecting those turbine blades to your N2 section, your compressor section, and that's what turns these blades. All right, and then the hot gases escape. That will also give you thrust. Or that's what gives you thrust. All right. In this case, we're just going to make a generator. So what we're going to do here is we're going to take power output. Now, you could replace the generator with a prop, a rotor, whatever you wanted, and then you'd get a turboprop or you get a turbo shaft. So let's start with a microcontroller and let's get this going here. So I'm just going to stick this here for now, and then I'm going to put all my controls. So my controls are going to be pretty simple. I want a throttle. All right. I want a toggle button. All right. I want a gauge. That's just going to show me my fuel. And I want a dial. This is going to show me my S watts. This is going to give me a kind of a visual representation of my power. Okay, so that's what I have there. Now let's not make duplicate microcontrollers. Let's make a microcontroller. All right, and this will be a jet turbine controller. All right, properties, jet turbine controller. Okay, so let's start adding our logic nodes here. So I want to bring in a, let me see, that's going to be my starter. Starter input is going to come from my toggle. I want a starter output. That's going to actually go to the starter itself. Output, starter. Okay, I want to take in my RPS. I want to take in my throttle, and I want to output my throttle. Again, the easiest way to do most stuff in game is a PID, so that's where we're going to go here. All right, so what do I have here? I have starter, RPS, throttle, and that. Let's go. Let's start with that, and I'll see if I need anything when I get it put together. Okay, so let's start with a PID. We'll do an advanced PID. I already know the number I want. I'm just going to start with 1. 1 works fine on this. So I'm going to do a property property number. My P value here is going to be 1. You could change this as you find, if it's not holding the value you want, but 1 should work fine here. All right, so I want my throttle to set the RPS that I want. Okay, and my process variable is going to be the RPS. It's going to read the RPS, and it's going to tell me if that's what it wants or not. Okay, so my starter here is going to go to my PID. That's going to turn my PID on and off. I'm going to do an AND. Okay, and so here I'm going to go starter and then I want a less than. All right, so this is going to set a condition that it's going to start my turbine if my button is on and if the RPS is less than, in this case, light off on a jet turbine is at 0.5. 0.5. And if you didn't know that, you can test it by seeing when the engine starts up. All right, so this is going to be my starter here. Okay. And then this will go to starter. So this will fire the starter off only when my button's on and when the RPS is less than 5. As soon as the RPS gets over 5, the starter will shut off. All right, clutch I need too. So let's put a throttle here. All right, and then let's add another node. The last node should be clutch. So this is a number output to the clutch. And I'm going to make an auto clutch here. So clutching is pretty simple. I don't want the clutch engaged when I'm starting, and then I gently and slowly want to increase the clutch. A lot of people put an on-off switch where the clutch just turns on. That shocks the system in real life. That would snap your shaft. Always better to add a clutch slowly, I find. So I'm going to do 0.001. I'm going to do a clamp of 0 to 1. All right. If the starter is on, so if this is on, I want it to reset my up-down counter to 0. Essentially, whenever we're starting, I want no clutch. Okay. And then if, essentially, I'm just going to reverse that less than. So I'm just going to do a not. So if the RPS is not less than 0.5, so essentially we're started, it's going to start to increase the clutch. So we'll start putting clutch in once the engine's started. All right, so this is a pretty simple, pretty basic controller here. All right, so now let's put some load on this. So you really need load on this, or else it's not going to really show you anything of note. And so the load could be anything. Like I said, it could be a prop, it could be a rotor. In this case, we're going to do a generator. We're going to make a generator that's going to inform us, you know, of it's going to put some load on the engine, but it's also going to show us visually with the with how many S-watts we produce. Okay, we'll take a medium generator here. Okay, and then I'm going to connect that via pipe. Okay, so I'm going to make this a 3 to 1. 3 to 1 right there. Okay, so let's start hooking this up. So we have starter. Starter goes to our combustion chamber. I'm sorry, our compressor right there. The starter goes to our toggle button there. Throttle is going to go to our actual physical throttle, which I'll change in a second. Throttle here is going to go to our compression chamber. Clutch goes to the clutch here. And then RPS, I'm just going to take off my compressor. All right, so that should set me all up here. So this dial here is going to give me S-watts. And then this gauge here is going to give me, it's going to go for my fuel tank. That way we can kind of see how much fuel we're burning. So I doubled everything up. Let me take that off here. I'm just going to get rid of these. These are just duplicates from me leaving symmetry on. All right, so let's go back in. Let's just connect all the electricity. And I'll add a battery in there, and then that way we don't need infinite electricity. Battery. All right, so I'm not going to go ahead and I'm not going to go into making this an actual generator and putting a microcontroller to that. We just want to get the turbine up and running and show you how that works. So let's now look at our throttle. So I'm going to go sensitivity like 50%. And then I'm going to go 0 to 100. Now 100 would make this blow up, but we have enough resistance here. We should be fine. All right, so first thing I'm going to do is instead of putting a 3 to 1, let me do a 1 to 1 and show you the importance of gearing. All right, so let's get this spawned up and started here. All right, so I'm going to go ahead. I'm going to set just a throttle value here. I'm going to set 10. That's 10 RPS that I'm looking for. Okay, I'm going to go ahead and press the toggle button. You'll notice once we hit 0.5 RPS, that starts and lights off our engine. All right, so that's too low. Let me see. Very simple problem. The tank starts with diesel in it. Make sure it's jet fuel. All right, let's try again. So here's 10. Forget that every time. And start up. At 0.5, this should light off. Okay, what's up now? Okay, do you have fuel? You have jet fuel. You do. Let me make sure this is connected. That is connected to there. Y'all merged? Y'all merged. Let's increase this value here. Let's go to 0.51. This was my problem. It doesn't light off till 0.5. I need it as 0.51. You can make that bigger, 0.6, whatever. It's not a big deal if your starter's running too much. I just had the value too low there. 0.5 is where it starts. I just had it right at 0.5, so it wasn't letting it start. Alright, see, that's all I needed. Alright, so it's up and running. Alright, so my PID is controlling it. I have it set to 10 RPS. It's probably never going to get there. It did. It's adding in the clutch. That's putting resistance on. That's building up electricity. Okay. Alright, so we're at 10 RPS, right? We set 10 RPS on our throttle level, 10.83. You notice we're at 10.44. That's fine. It's close. Let's look at our fuel. See how what we're burning for fuel and see what we're making for S watts. Let's go all the way up to 100. Now, we're never going to get to 100 because there's enough resistance here. It should keep us below 100. So let's look. All right. We're going to get up probably around 60. All right, so we're doing 60 RPS on this turbine. Look at the S watts. We're making 1100 S watts. So if you need to make a gobs of electricity, turbine is the way to go. Power generation in real life and the way it works in game are pretty similar. You want high RPM, low torque to do electrical generation. A turbine provides high RPM, low torque. You need to do torque conversion with gearboxes to get more torque. All right, but let's look at our fuel. All right, jet fuel is the most expensive fuel in game, and we've already eaten more than half of our tank in that short period of time. All right, so burning around here at 66 RPS, you're going to use an insane amount of fuel. All right, this is why jets in game will use a ton of fuel, is because you're going to be at a high RPS, pushing out thrust, and you're just going to be burning up a ton of fuel. All right, so look, our tank will be out here in seconds. All right, that's 700 liters of jet fuel. Jet fuel in game can cost as much as like 16 bucks a liter. You know, so you're talking thousands. You know, you're talking thousands of dollars for that little bit of electricity we just made there. All right, so now let's just go into gearing here. So let's just spin this right up to a 3-to-1 gear ratio. All right, now, so we were at 1100 S watts. Let's start up our turbine again. Let's just go to 100. We'll never get to 100 because we've added so much extra resistance with the 3-to-1 gearbox. All right, here we go. All right, let's see where it goes. The clutch is going to start adding in. You'll notice our clutch is automatically adding in. Because our clutch is adding in, there goes our S watts coming up. All right, so we have 100% clutch. That's putting resistance on our turbine. So as you can see, even though I have my RPS set to 100 is what I'm asking for, it's only giving me about 9, and the reason it's giving me 9 is all of this resistance. Now, the lower the RPS, the lower the RPS, the less fuel we're going to be burning. All right, so that's the benefit. Now look at the fuel. We're still burning about a liter a second. We're making 193 S watts, which is a lot less, but we're actually operating at a reasonable fuel burn. Now, still, I would not recommend making a turbine power generation system on the ground. It just does not make any sense to me. It's too expensive. It burns too much fuel. I would go with diesel. You want to make a turbine when you're doing a turboprop, a turbo shaft helicopter, or a jet airplane. All right. So, but as you notice, this very simple controller with a p-value of 1, it keeps us very close to where we want our thrust. You know, like let me set this to 8. All right. So the reason it's doing that is the p-value is probably too high. Probably be downed, but. All right, so you see, we're going to have a little bit of lag off there just because we're also getting resistance that it's not accounting for. But so right now, as you can see, we can dial down our power here. All right, so this is a pretty basic controller on a jet turbine here. It's showing you how you'd connect it, how you'd set it up, what the applications are. So any power you may want, if you want a turboprop, a turbo shaft, this is the setup you want to do. You need these components. Now, let me make this a little bit more powerful. So let's go back up to 100%, and I'll show you one last kind of quote-unquote trick. This is not how it would work in real life, so it kind of makes my brain hurt from actually having experience with this in real life, but this is how it works in game. So again, let's look. We're capping out around 9 RPS because we have a 3-to-1 gearbox turning this generator. This is all resistance. Alright, this is doing work. So this is like having a prop on there or having a turbo rotor for a turbo shaft. So we're producing 193 S-watts, which is a lot of power. As you can see, we've already burned down about 200 liters of fuel in a short period of time. So this is not an inexpensive way to make electricity in game. Diesel would be the way to go. All right. So let me show you one more thing. So let's look at our numbers here before I show you this quote-unquote trick. So we're at 9.2 RPS. All right. We're producing 193 S-watts. 9.2, 193. Let's recall it. All right. If we want to make a more powerful turbine here, we're going to add some more turbine sections. So let's add 2. Let's add 1, and let's check the numbers there. Okay, so all I'm going to do here is I'm going to cut there. Let's go pipe. All right, let's connect this. So essentially what we do is we have hot gas expansion coming off the compressor. It's turning the turbine blades. We still have excess hot gas we can use, so by adding another turbine section, we're taking more power. So this is how the game does it. This is not how real life works at all. You need a more complex compressor section. You need more N1 blades. You would need more turbine blades. There's a bunch of things you need in real life, but again, this is just in game. So by adding an extra turbine section, let's see if we can get more power out of this for essentially the same fuel burn. All right, so this is how you can modularly change the power of your turbine. So let's go back up to 100. Let's turn it on. All right, we'll watch our clutch come in. Here comes our clutch. All right, so again, I have it set up this way so it gently adds the clutch so it's not shocking the engine and just killing the engine right away. All right, so we're doing 9 something RPS. We're doing 193 S-watts. Okay, so as you see here, we're at a higher RPS because we added that extra turbine section. We're making a lot more power. Let's decrease it down to about let's go down to 9 RPS. So we want to make our test look the same. So go to 9 point. We're at 9.3, but let's go 9.17. Let me try to get this RPS to 9. Okay, so that's about where we were. We were around 9.23, I think. Let's see what we're producing for S-watts. 192. All right. So see, because it's essentially the same gear ratio, we're back to where we were. All right. So the maximum we could make was 9.25 RPS at full throttle before. All right. So this is back to where we were. That extra turbine section is giving us more power so that we can essentially throttle up more. Alright, so it's not saving us any fuel, it's allowing us to have a higher RPS. So before where our turbine speed was capped at 9 RPS, we're now able to go up to 13. Well, because we're able to go up to 13, we're producing 414 S-watts, which is more than double what we're producing in energy. Alright. So by adding that turbine, we're able to go up in RPS, which is making it more powerful, which is going to give us a higher prop rotation, which gives us more speed, or a higher rotor rotation, which gives us more speed, or allows us to produce more power for a generator. All right, and again, this is not a good application for a jet turbine. Look at how fast we're burning fuel. All right, if you want to put on infinite fuel, that's great, but a turbine is not a good use for a power production game, in my opinion. It's just too expensive. You know, let's look at a map really quick. Let's find what some. Let's look at the. No, I don't want to fast travel. Let's look at the. Where is it? Right here. We could buy some jet fuel. We could buy jet fuel for $3.72 a liter. Alright, so that tank there is 700 liters. So that we're talking 2,100 liters of, or $2,100 is what it would cost us to fill this tank up. And in less than 10 minutes, we're going to be out of fuel. Alright, so this is a very expensive way to make electricity. I would say if you're going to make electricity, go with a diesel every day of the week. Alright, so I'll do one last little test and we'll end this video. Again, so as you can see, we're at 13.5. We're making 414. So the real benefit of adding extra turbine sections like that and adding extra power is the ability to add more gearing and get more efficiency. So if you want to get more efficiency, you don't want to be burning a ton of fuel, you need to add more gearboxes. And so let's try to set this gearbox up here so that we can... So I want to get my RPS back down around 9. So let's try this. Let's go a 2-to-1. Oh, 2-to-1. So we're running a 3-to-1 gear ratio. Now a 2-to-1 times a 2-to-1, 2 times 2 is 4, 1 times 1 is 1. That's a 4-to-1 gear ratio. So let's play with this on a 4-to-1 gear ratio. Alright, so that's adding more resistance. Let's get this started. And this will be our last little test. You know, you can extrapolate from this. By adding more turbine sections, you're able to add more power, which allows you to add more gearing to get more power out of your engine. Alright, so as you can see, we're able to go to a higher RPS because we have more power. Alright, so now the clutch is all the way in. Alright, so perfect. This is getting us back down around, we're below 9 S-watts. Or we're below 9 RPS, but look at our power. Alright, so remember, when we had one turbine, we were doing about 9.6 RPS, right? So that gives us a certain amount of fuel burn. The lower RPS, the less fuel we're burning. And we're making 193 S-watts. We're now up to 253 S-watts. Alright, so we're making more than double the S-watts. And we are burning less fuel. So by adding an extra gearbox, by increasing our gear ratio, and by adding a turbine section, we're able to make a turbine that burns less fuel and makes more electricity. So that's the direction you want to go if you want to try to get an efficient, jet turbine to produce electricity or make power. But let's still look at it here. We're still burning about 1 liter per second. All right. That's 700 liters there. That's 700 seconds. Alright. So it's at 10 minutes, a little bit more than 10 minutes of fuel. That's $2,100 of fuel in 10 minutes. So every 10 minutes you're burning $2,100. So if you're trying to use this to move a container, that container better be worth some money. You better get it there within 10 minutes or else you just lost the value of the container. So just some things to keep in mind, but this is really quickly how to set up a jet turbine. Thank you for watching. Bye.